start. Hello everyone. I will tell you today the energy level diagram to show the splitting of the d orbital in octahedral and tetrahedral field. So first we have to know what is d orbital. D orbital, first of all, orbital means the space where electron can be present. The three-dimensional space around atom where electrons can be present. Now there are different orbital, s orbital, p orbital, but here in complex formation we have to choose d orbital because d orbital can form different types of complex. Now d orbitals, there are two types of d orbitals. There are some d orbital dxy, dyz, dzx. If you draw their structure or their orientation, then we can see in dxy, this is the dxy d orbital, this is x-axis, y-axis. So dxy d orbital means this is oriented in between x and y-axis. It means electrons, if present in dxy orbital, means their orientation or their position will be in between the x and y-axis. Similarly, dyz means in between y-axis and z-axis. So this is y-axis, this is z-axis, and this is our orbital. This is our orbital, means electrons will be present in this place. So it means in dyz, it means the electrons are present in between y and z-axis. Similarly, if we take dzx, the electrons will be present in between x-axis and z-axis. So this will be the position of the electron in dxz or zx or xz axis. So it means these three orbitals, dxy, yz, zx, they can come in a category of the orbitals where the electrons are present in between axes. Okay, these things we have to know first. That electrons present in dxy, yz and zx means they are present in between axes. Now if we come to the another category, another category is dx square minus y square and dz square orbital. Dx square minus y square means this is x axis minus x, y minus y. X square minus y square means orbital is oriented along x axis and along y axis. It means the electrons present in dx square minus y square in this orbital, so electrons are present along the x axis and along the y axis, right? So it means dx square minus y square, this orbital is oriented along the axis. It means if any electron present in this axis, it will be present along x axis and y axis. Now come to the dz square orbital. Dz square actually is a linear combination of two orbitals. One is dz square minus x square, another one dz square minus y square. It means we have two different orbitals. One is dz square minus x square means along z axis and x axis. Another one dz square minus y square means along z axis and y axis. So if we draw dz square d orbital means it will come, we will get one lobe along z axis and we will get another lobe along xy plane. It means electron present in dz square orbital means electrons is present along x axis, along y axis and along z axis. In all these three axes, electrons are present. Okay. So dz square and dx square minus y square, these two orbitals are coming under category of along the axis, right? So d orbital, what we have learned that d orbitals can be categorized into two sets. In one set, electrons are present along the axis. Example dx square minus y square and dz square, and another set electrons are present in between the axis, like dxy, yz and zx. Okay. Now we will come to the next part, that complex formation. What is complex formation? Complex formation means, let's say we have a metal. In this case we are talking about transition metal. Transition metal means scandium, titanium, vanadium, chromium, manganese, iron, nickel, cobalt, nickel, copper. These are the transition metals. Why we are talking about transition metals? Because transition metals has a d orbital. So if we have a metal, if we take x number of ligand, we will get a complex like MLX. It's a complex compound. Here there is coordinate bond present between ligand and metal. Okay. So we know different type of bond, ionic bond, covalent bond. But here the bond is different type. This is called coordinate bond. Coordinate bond means the ligand will donate their electron to metal. Then it will form this coordinate bond. Since metal is taking electron, it is a positive charge or it has some vacancy. Means it has a electron deficient. So metal is positive charge, electron deficient. Because of that, it can take electrons. Since it can take electrons, we can call metal as a Lewis acid. Now ligand can donate the electrons, so we can call it a Lewis base. So in metal ligand complex formation occurs after this Lewis acid base interaction. And then ligand to metal electron is coordinated and we are forming a coordinate bond between metal and ligand. It is not ionic, it is not covalent, it is coordinate bond. Now in our syllabus we have two types of complex. One is tetrahedral complex, another one octahedral complex. When there is a full number of ligand ML, it can be two types. One can be tetrahedral or square planar, but we will talk about the tetrahedral complex because our discussion in this part is octahedral and tetrahedral complex. So when there are full number of ligand attached with the metal, it will form tetrahedral complex. When 6 number of ligands are attached with the metal, it will form octahedral complex. Example, if we take cobalt 2+, it is a transition metal. Now if we take cobalt 2+ and react with 4 number of Cl-, it will form COCl 4 2-, right? Cobalt 2+ and 4 number of Cl-. It is an example of tetrahedral complex formation. If we take iron 3+ and then 6 number of Cl-, then it is forming FeCl6 3-. It is an example of octahedral complex formation. Okay, so these are the two examples of two complex formation. Now come to this part. This is our tetrahedral complex TD, where cobalt is present at the center. There are 4 ligands Cl-, they are oriented around this cobalt. Now if we check the orientation will be in between the axes. Say this is our cobalt, so it is our metal, and ligands, when this tetrahedral complex is forming, ligands are coming in between the axes. Say ligand 1, ligand 2, ligand 3, ligand 4. So 1, 2, 3 and 4. So these ligands are coming through to metal through in between the axes. They are not coming along the axis. So ligand 1 is coming, let's say, between x and y axis. Ligand 2 is coming between, let's say, z and x axis. Okay, like that ligand 3 and ligand 4. All are coming through, all are coming in between the axis. So ligands approach through in between axis to the metal. So to form tetrahedral complex, ligands is coming through in between the axis. And in this tetrahedral complex, there will be no center of symmetry. Center of symmetry means if we consider some center here in the middle, we will not get any center of symmetry in tetrahedral complex formation. Now, if we have the d orbital, this is the 5 d orbitals, right? dxy, dyz, gzx, dx square minus y square, dj square. These are the 5 d orbitals are present. Initially, the energy of all these d orbitals will be same, because all are in the same level, same energy, so it will be called degenerate d orbital. Now, when ligands are approaching to the metal, what will happen? So, ligand has a negative charge, right? All ligands are negative charge. And cobalt 2+ means it has D7 iron, then cobalt. So, it has D7, so 7 number of d electrons are there. So, metal, it has already electrons and ligands are approaching, so ligands has also electrons. Now D7, all these 7 electrons will be here. 1, 2, 3, 4, 5, 6, 7, right? So all these 7 d electrons are there. Now when ligands are approaching to metal, what will happen? There will be inter-electronic repulsion between electron present on the ligand like Cl minus and the electron present in the metal. So metal is here, so metal is surrounded by its d electron. All these d electrons are present in this 5d orbital, dxy, yz, zx, x square, y square, dz square. When ligands are coming, ligands has also negative charge, Cl minus here. So these two negative charge will repel each other. Because of that, the energy of the d orbital is now going to be shifted. Now, since ligands are coming in between the axis, right, in between the axis, so the d orbital which are oriented in between the axis, because of that inter-electronic repulsion, their energy will be increased, right? Now, what are the orbital oriented in between the axis? We already know dxy, yz, zx. These 3 orbitals are oriented in between the axis, right? Since they are oriented in between the axis, right, and ligands are approaching in between the axis, so inter-electronic repulsion will be high in these 3 orbitals, dxy, yz, and zx. Because of that, the energy of this dxy, yz, and zx it will increase, right? Now, to compensate this energy difference, the energy of the other 2 orbitals means dx square minus y square and dz square, it will decrease. Initially, it was the energy level was here. Since the energy of this 3d orbital is increased, the energy of the other 2d orbital will be decreased. Since conservation of energy, we have a law, right, in physics, to conservation of energy. So to maintain that law, the energy of the other d orbitals it will be decreased, right? Then what will happen? Now these 3 orbitals dxy, yz, their energy is high, and other d2d orbital means dx square minus y square and dz square, the energy will be low. Now these 3 orbitals having same energy, so it will be called T, triplet. 3 orbitals same energy, so it will be called triplet, T2. And there is 2 orbitals same energy, it will be doublet, E. Okay, this doublet is indicated by this E letter and triplet is indicated by this T2. Now, in tetrahedral complex has no center of symmetry. Because of that, we can't say it is graded or ungraded. So therefore, we will not write any G here, only T2 and E. So this is the splitting of the d orbital in tetrahedral complex formation means tetrahedral field. So in question there is tetrahedral field. Tetrahedral field means the ligand field. So ligands, when there are 4 ligands coming to metal forming a tetrahedral complex, it will generate a field, a negative charge field that is called tetrahedral field. And in this tetrahedral field, this is the splitting pattern of the d orbital. dxy, yz, zx energy will increase, and dx square minus y square, dz square, the energy will be decreased. The energy gap between this E level and T2 level, this is the called splitting energy in tetrahedral field delta T. So delta, it is called splitting energy. So delta, this is called splitting energy. Okay. Since it is tetrahedral field, I have written here T. And this dotted line, by the initial energy of the d orbital, this dotted line is called barycenter. Now from barycenter to T2, the energy gap is plus 0.4 delta T, and this barycenter to E, the energy gap is minus 0.6 delta T. It means if we have some electron here, the energy of the electrons will be minus 0.6 delta T. And if we have some electron here, the energy of the electron will be plus 0.4 delta T. Okay. Now come to the next one, octahedral field. Octahedral field means, example is our this complex FeCl whole 6 3 minus is the example of octahedral complex. Now if we draw the structure of this complex, it will be like this. Iron will be at the middle, and there will be 6 number of 1, 2, 3, 4, 5, 6. There will be 6 number of cyanide ligands surrounding this iron metal, and overall charge will be 3 minus because iron plus 3, and there is total 6 number of negative charge, so plus 3 minus 6, it will be minus 3, right? So because of that, overall charge of the complex will be 3 minus. Okay. Now this is the complex. Now if we check the approach of the ligands to metal, so metal will be at the center, x axis, y axis and z axis. In octahedral complex, all this angle is a 90 degree. Angle between these two coordinate bond is 90 degree and these two coordinate bond is also 90 degree. Right? So this is possible only in angle between x and z axis is 90 degree and angle between x and y is 90 degree. So when this octahedral complex is forming, so ligands are coming along this axis. Because of that only finally we are getting all this angle 90 degree. So ligands are approaching along this axis. This is the conclusion. So what will happen if ligands approach along the axis? So before ligands were approaching in between the axis. Now if they are coming along the axis, so in this case we have iron 3 plus means D6, right? Iron 3 plus means D6. It means, sorry, not D6, it will be iron 3 plus will be D5. Okay, so it means there will be 5 number of D electrons, right? So means all the orbitals are initially filled by the electrons. So metal has an electron, ligands has also electron. So when ligands are approaching, so there will be inter-electronic repulsion between metal electron and ligand electron. Cyanide minus is our ligand. Now ligands are approaching along this axis. So the electron present along the axis means the dx square minus y square and dz square. These two orbitals are present along the axis. So it means when ligands are approaching along the axis, the energy of this dx square minus y square and dz square it will be increased because they are present along the axis. So their energy will be increased. Since their energy is increased, the energy of the other 3 d orbital it will be decreased. Therefore, in octahedral field means when the ligand is coming to form an octahedral complex, the splitting pattern of the d orbital will be like this. The energy of dx square minus y square is higher and energy of dxy, yz and zx is low. Now there is 2 d orbital having same energy. It will be indicated by this E and it is called G because in octahedral case there will be a center of symmetry. Means if we consider this a center, now from this center if we move in this side we will get cyanide. If we move in the back side there will be cyanide. From the center if we move in this side we will cyanide, in back side also there will be cyanide. So there is a center of symmetry. Since center of symmetry is present, d orbital is called garret. To indicate this garret we are writing as Z. Okay, so it is called Eg and there is 3 d orbitals dxy, yz, zx, same energy. So 3 plates, so T2 and Z. This G is we are writing for octahedral complex only because the octahedral complex has center of symmetry. In tetrahedral case we will write only T2 and E. There will be no center of symmetry, because of that we will not write G. Now the gap between this Eg and T2G is called delta 0, delta O. Delta is called splitting energy. In octahedral field it is in octahedral, to indicate the octahedral field we are writing a O. Okay. And this the center is called barycenter, this dotted line, the initial energy of the d orbitals. So barycenter to E the energy gap is plus 0.4 delta O and barycenter to T2G minus 0.4 delta O. It means if there is one electron here in this level the energy will be minus 0.4 delta O. If there is one electron here the energy will be plus 0.6 delta O. Okay. Now we can see here in octahedral there are 6 number of ligands. In case of tetrahedral there is only 4 number of ligands. So now more ligand means much more negative charge, more negative field. So octahedral field is much more stronger field than tetrahedral. So if we check the splitting energy, so splitting energy in case of octahedral